Alright, so in this video I'm going to take you through a couple problems on the CFA 3A review. So the first set of problems is properties of exponents. So simplify, your answers should contain only positive exponents. So looking at number 1, we are multiplying, so we multiply our numbers in front. So 4 times 2 is 8. N to the 4th times n to the negative 3rd. We add our exponents, so we get n to the 1st, or just n. With number 2, we have 4a cubed b squared all squared. So this squared just gets kind of distributed to each of those. So we have 4 squared, a cubed squared, and then b squared squared. So 4 squared is 16. A to the 3rd squared, you multiply those exponents, so you get a to the 6th. B squared squared, you multiply those exponents, so you get b to the 4th. The last one, it looks a little confusing. We have to do some switching around with our values. Everything that has a negative exponent needs to switch places. So negative exponents go to the denominator. If they're already in the denominator, they move to the numerator. So we are going to switch around this guy, and then this guy. Everything else will stay the same. So I'm going to have 2x to the 4th. That y to the negative 3rd is going to come up top to y to the 3rd, over 3x squared. Y to the negative 4th is going to drop down and become y to the 4th. And then z to the negative 3rd is going to drop down and combine with that z to the 4th. So if you have 3 and then 4, you have 7 total. Okay, so now we can simplify. So 2 over 3 does not simplify any further than that. So we will have 2 over 3. X to the 4th over x squared. There's 4 on top, 2 on the bottom. We can cancel 2, and there is 2 left on top. Y to the 3rd divided by y to the 4th. 3 on top, 4 on the bottom, so we can cancel 3, and there is 1 left on the bottom. And then z to the 7th is left in the denominator. The next section is write each polynomial in standard form, then classify it by degree and number of terms. So standard form is with the largest exponent first and then in decreasing order. So for number 4 here we have 4x to the 3rd plus 6h squared plus 1. That is standard form. The name of the degree, so this is a degree 3. It is a cubic. And number of terms, there are 3 terms, so we call it a trinomial. The next section, given the graph, determine whether A, the degree is even or odd, and B, the leading coefficient is positive or negative. So I had given you a chart a while back talking about end behavior. You might want to reference that chart here. Looking at number 6, since my end behavior is going down, down, it is an even degree. Think about a quadratic function. The end behavior is either up, up, or down, down, depending on the leading coefficient. And so in this case, since it is down, down, my leading coefficient is negative. Number 8, graph the function below and identify its key characteristics. So we have 2x cubed minus 4x squared minus x. So we need to graph this guy, and this is what the graph will look like. So that's what the graph will look like. You can get that from Desmos.com. Now let's talk about the key characteristics. So the domain, again, domain for any polynomial function is from negative infinity to positive infinity. The range is what could change. So in this case, my function is going down, starting down, so from negative infinity, and then it just keeps going up. Okay, so it's going to go to positive infinity. That's your range. You have some relative maximums and minimums. So again, you would need to find these using Desmos because they are decimal points. The relative max is negative 0.115 and 0.059. The relative minimum is 1.448 and negative 3.763. Next, let's talk end behavior. So as x goes to infinity, f of x is going where? So positive infinity in the x direction is to the right. So on the right-hand side, where is my graph going? Well, it's going up towards positive infinity. As x goes to negative infinity, which means to the left, where is the graph going? In this case, it's going down to negative infinity. Okay, now we have intervals of increasing and decreasing. So increasing is where the ant is crawling up the hill. So in this case, it would be this section and this section of graph. Okay, so my increasing intervals is going to be from negative infinity until that x value of that maximum, so negative 0.115. Union, if we have two intervals, we connect them with a union. The x value of that minimum, 1.448, to positive infinity. That's where the function is increasing. Decreasing intervals is in between the max and min there, so we have from negative 0.115 until 1.448. That is where the function is decreasing. We also have zeros. Again, it's kind of difficult to look and see what they are. You'd have to have Desmos up to get the exact value. But you have zeros when x is equal to negative 0.225, 0, and 2.225. Those are your zeros. Okay, next section, identify the zeros, their multiplicity, and the effect of the graph, the effect on the graph of the function. So number 9 here, we have x squared times x minus 1 to the 4th times x plus 5. So to find your zeros, you set each factor equal to 0. So x squared equals 0, x minus 1 equals 0, and then x plus 5 equals 0. So with x squared equals 0, that's really two x's there that are equal to 0, so your 0 is at 0, multiplicity of 2, and the effect is that it will bounce. At x minus 1 equals 0, solve for x, so add 1 to both sides. Your next 0 will be at 1. And the exponent of the original function will tell you the multiplicity. So it has a multiplicity of 4, and because it's an even multiplicity, it will bounce. Then x plus 5 equals 0. Solve for x, you get negative 5. That one happens once, so it will cross. Number 11, a polynomial function has zeros negative 1, 2, and 7, all multiplicity 1. Write a function in standard form that could represent this function. So if we have zeros of negative 1, 2, and 7, all with a multiplicity of 1, which means they happen once. So we need to get each of these equal to 0. So I'm going to add 1 over here. So I'm going to have x plus 1 equals 0. X minus 2 equals 0, and then x minus 7 equals 0. These are my factors. Okay, so in my polynomial function here, I'm going to have x plus 1 times x minus 2 times x minus 7. Okay, this is in factored form. We need it in standard form, so we need to FOIL. So first I'm going to FOIL these first two here, so I will get x squared minus 2x plus x minus 2. Okay, and I'm just going to simplify this really quick. So negative 2x plus x will give me negative x and minus 2, and then x minus 7. Okay, so now we need to multiply this binomial here. So I'm going to distribute in that x to each term. X cubed minus x squared minus 2x, and then distribute in the negative 7. Okay, so negative 7x squared plus 7x plus 14. Add them together, and I will get x cubed minus 8 x squared plus 5x plus 14. And this is my polynomial in standard form.